We're excited to have Sal back on the curriculum. I think most people know Sal, and in the semester offerings, you read the bio on him. I just wanted to mention one other thing that Sal does. If you might have seen the video on Meals on Wheels, Sal was selected as one of their exemplary deliverers to be featured in a Super Bowl ad that ran on NBC. And they have about 3 variations of the ad, and it's still running. So if you haven't seen it, tune in, especially in the mornings on NBC, and you'll get to see Sal in action. One other thing that Sal is known for, he's a hiker, and he goes out to Kennesaw Mountain a lot with groups of people, a lot of the Suga visitors like Lauren. And so he's jack of all trades, as they say. So yesterday, somebody offered me some free things. And so this is coming to Sal, if I can get it to show. It's a neckerchief with all the Georgia state parks and historic sites on it. You can check them off. So in all your spare time.
Well, great. Thanks, George.
Okay, so Sal, it's all yours.
Okay, well, thanks. Welcome back, everyone. I wanna start the class by first paying, let me see here. I first want to, pay respect to Florida law. For those of you who are not familiar with it, let me, where did it go? Here we go. Should bring it up. No, okay. You have me spotlighted. So I'll stop that share and I'll do another one here. Sometimes these things don't cooperate, but we'll get it. Where did it go? Here we have that, and I have that. And then, sorry, this, we've had a few things. There we go. Share the screen. Share the screen. And this is important, really, because hopefully you're now seeing Salon, George.
Yes.
Okay. I wanna, pay respect to Florida's proposed legislation, which requires instructors to express their political views. You need to know what my political views are. And this is what will be happening in Florida if DeSantis's bill gets passed. Professors will have to, account for their political views. And so it's important. I have political views. I'm not quite sure how you would classify them. I mean, I'm against, insurrections, but I'm also against, things on the other end of the spectrum. But if anybody is really interested in more of my political views, I'd be glad to answer it. So that is our latest from Florida, where you are not allowed to say gay or something like that. Anyway, so what we're going to do here is, and so, it's important for me to say to you that my teaching style is that I'm not a historian, I'm not a scientist, I'm a consumer of the works of historians and scientists. So I'm a consumer, I take their works and I put them together into classes. And so what I like to do is to highlight key points, and then to show you videos of the experts making those points. You will see some videos that will be repeating points that were made. And I do this to show that the point that's being made is coming from various sources. So, you're getting, Professor so-and-so says this, and another professor says the same thing, to know that this isn't just one person's wild idea. In doing this class on the history of the Earth, I want to say that I find this material very interesting. I hope that you will. The idea that the Earth was born 4.6 billion years ago continues to astonish me. Because when you consider that we have been around for 200,000 to 300,000 years, it puts the human experience into a perspective, into a context, that this planet has been around a lot longer than we have, and it should put us into a certain sense of being humble in the presence of things that have been here and have outlasted what has been our existence. And I guess I find it astonishing when I look back on what I was taught as a child. Certainly my religious upbringing suggested that Earth began about 5,000 years ago. Everything was created, and here we are. And so for many years of my life, that's what I thought was the case. Of course, science has come to say, no, it actually starts a lot sooner than 5,000 years ago. And so I just think it's important to kind of put these things into perspective. I also feel that from a religious context, it's interesting to think about this planet being here for the length of time that it has. And when did ideas of God come into being? When did they emerge? And so if we look at ideas of God going back 4,000 and 5,000 years ago, the ideas that we currently hold about God, not the transactional pagan gods, but just the idea that we currently accept that it is just about 4,000 years old. And so it helps to put that into some context. And so it raises questions, and I don't presume to have answers to that, but here are just some questions that I think are worth considering. And that is God a human contrivance? How was God present before humans came along? Perhaps God isn't a human contrivance, and God was present long before we came into being. And it's kind of, I don't know the answer as I say to those questions, but as I look at the history of Earth, those are some of the things that I like to contemplate. It may also be suggested that the dinosaurs, who dominated the planet for 180 million years, and in that domination, they forced the smaller living organisms to go underground and to hide. And so then there comes along, perhaps it was God that was displeased and punished the dinosaurs with a meteor, ultimately killing off the dinos. The smaller organisms then come above the ground, come above the surface, and they thrive. And indeed, our ancestors are part of the survivors from the dinosaur period. And perhaps, this is really the essence of the meek inheriting the earth. So some of these things kind of run together, and I just think it's interesting to try to contemplate that. It's also important to know that by 2050, it's estimated that 30% of Earth's surface will be underwater. What we currently have is Earth's surface, 30% of it will be underwater by 2050. Could this be punishment? If there is a God, perhaps God is sending us a signal. So I just think as we look at the science, it is interesting to look at some of these other issues and to see how they relate. These 6 classes, we're going to start with the pre-geologic period, 4.6 to 4.3 billion years ago. Then we're going to look at Rodinia of 1 billion years ago, Panatoa Gondwana of 600 million years ago. Then we'll address Pangaea, 300 million years ago. Then the period of the dinosaurs and the mammals when they emerged 245 million years ago. And then we will look at global warming and what scientists predict as not to worry about global warming because an ice age is looming in the future. So that's kind of the landscape of where I plan to go with this. And, you know, it starts with a supernova explosion, be it a star that explodes sometime 4.6 billion years ago. Out of that comes a solar system, the solar nebula, that circles around the sun. That is, the gravity of the sun holds them together and forms what become the planets of our solar system, of which we are, the Earth is but one element of that solar system. But Earth begins as a cloud. It is a cloud, and what we know of as the Earth was merely a cloud that was a swirling liquid rock and dust. It was a ball of fire with temperatures of up to 2,000 degrees. Another early planet, Theia, collides about 4.5 billion years ago, resulting in the formation of the moon. And the moon was very close to us, maybe 14,000 miles away, whereas today it's 250,000 miles away. The moon, it's a product of Theia, which could be, you know, a meteor that collides with the Earth and then forms the mass that becomes the moon. Meteors along the way, though, continue crashing into the planet, and they're depositing molecules, including water. Water comes in crystals, very small amounts, and over the long period of time, it comes to cover the planet. And we have volcanic activity. The gases in the core of Earth continue to erupt and create island surfaces that eventually emerge above that water. And through this process, these meteors are introducing what become the basic elements of life. They continue to, the meteors collide, and with those collisions, they bring nitrogen, carbon, hydrogen, oxygen, phosphorus, sulfur, all of which become as the essential elements that will create us. And we'll look at how that happens. The significance of it all is that the planet, for me, the significance of the whole study is that the planet starts as a cloud of liquid rock and dust, solidifies over billions of years, then it forms a core, a mantle, and a crust. So we get to see what is the world that we live in today. Okay, so let me introduce you. First, I have to switch this one. Get that up, get him out of there, and go to that. And
where did we come from?
No. Sorry. Get back over here soon. You gotta collapse down. I have my, come on, there we go. There we go, share that screen. Got it.
He needs new background material.
Our history in the cosmos and on planet Earth was shaped by countless events, some obviously epic, some seemingly trivial, yet all vital in getting us to this point, here and now, the people we are today. One of the reasons we're here, that we exist at all, is that Earth, cosmically speaking, is in a relatively peaceful place, orbiting our sun in a near-perfect circle. Our cosmic neighborhood has granted life billions of years to evolve, mostly undisturbed. But where did this stable piece of real estate come from? We know that stars and planets, once upon a time, all started out like this, with enormous clouds of gas and dust. How we got from here to here, we haven't exactly figured out yet. But lately, we found some intriguing new evidence that tells us our peaceful solar system may have started with a violent event. If we want to unlock the secret behind the origin of our sun and its planets, it would be helpful to find some remnants from the birth itself. An event that took place about 4.5 billion years ago. But wait a minute. A supernova is one of the most powerful explosions in the universe. It's so luminous, it can be seen across billions of light years. It releases as much energy in an instant as our sun will produce over its 10 billion year lifetime. So how could a baby solar system survive such a violent, destructive event? Well, turns out, some researchers think the reason we survived is that the supernova explosion was actually the trigger that created our solar system in the first place.
The one question that we're trying to understand right now is, could such a supernova actually have been involved in the formation of our own solar system?
Alan Boss is one astrophysicist convinced that we owe our existence to a supernova. He thinks it happened like this. Like everything else in the universe, we started out as a cloud of gas and dust. Then, a distant massive star died and went supernova, sending a shockwave toward us. When the wave of pressure hit the cloud, it collapsed and condensed, starting a chain of events that led to the formation of our sun. You can think of it kind of like a snowplow. You can create mounds of snow or destroy them.
We can do either or.
So you are the supernova of the ski slope.
That's for sure.
As the plow pushes through a parking lot of light, fluffy snow, the snow clumps together in bigger and bigger chunks.
Okay, I just want to interject here that they're trying to demonstrate is that as that cloud continues spinning, the rocks, the dust, the gases, they start to accumulate, they start to come together, it's like when you see the dust when the sunlight comes through your window and you see those dust particles in the air, they're all little pieces that, if it wasn't for the sun, you wouldn't see them. But then they start to accumulate with each other, and then you see that ball of dust on the windowsill. So it's that kind of thing as to how this Earth forms. Again, it is a ball of fire, rocks, and dust. And this is how it comes together into a solid form.
Out in space, pressure hitting a gas cloud has a similar effect. Except, instead of snowballs, you get stars. Once you've got the makings of a star, gravity draws leftover gas and dust into a giant swirling disk. The dust continues to stick together, clumping into rocky asteroids, which eventually become orbiting rocky planets. And voila, a solar system. So is this where we came from? Well, not everybody's buying the supernova as a creator theory.
What remains a little bit controversial about that idea is that you can't have that fluffy cloud near the supernova. When that shock wave is just coming out of the supernova explosion, it's super strong.
For Steve Desch, a supernova hitting a gas cloud is more likely to do this. Like a snowplow in overdrive, a supernova shockwave might sweep away any gas clouds in its path. Desch thinks something gentler triggered the collapse. A shock driven by radiation from a massive star. But Alan Boss has crunched the numbers and insists that at the right distance, a supernova shockwave would be transformed from a destroyer into a creator.
We believe that our own solar system was a cloud sitting there in space, more or less minding its own business, when a supernova shockwave struck the cloud and have it collapse down and form a new star system.
We still don't know for sure what the trigger was. But since we've discovered meteorites with supernova dust, we do know that a violent explosion rocked our cosmic neighborhood at the time of our birth. And it's quite possible that without it, our stable, stately solar system would never exist at all.
Now, mind you, much of what we now know about the solar system and our and the formation of the Earth is material that we've only learned about over the past 200 years.
World. But just over 200 years ago, all this would change. Scotland, the Edinburgh coast. It was here, one day in 1788, that the discovery of a small rocky outcrop would completely rewrite the history of the Earth. Geologist Geoffrey Bolton is on his way to the desolate Siccar Point, where this discovery was made by a maverick Scottish farmer, James Hutton. Hutton was to become the father of modern geology.
Hutton was a man who was enthusiastic in the pursuit of truth, a very inquiring mind. When he took over his father's farm, he saw underneath the soils rocks and wondered what these were.
Hutton spent years obsessed with understanding how the rocks of the Earth were made. His intrepid field expeditions took him all over Scotland, and they led him to realize that extremely slow processes could create the rocks he saw from layers of sediment.
He rode miles and miles on his horse to go places where he thought he could find exciting geological experiences, even though he suffered terribly from saddle sores.
Hutton concluded that rocks could take hundreds of thousands of years to form, but his claims were speculative, and his radical ideas flew in the face of the accepted version of Earth history, provided by the Church. For generations, the Christian Church had been the sole authority on all creation, based on the book of Genesis. And using the biblical genealogies, church leaders were now confidently claiming they knew the exact age of the Earth itself.
Archbishop Usher in the 17th century had calculated that the Earth was 6,000 years old, and indeed He calculated that it was made on October the 14th in the afternoon.
Hutton was convinced that the Earth had to be much older. And when his explorations led him to Siccar Point in 1788, he would finally find the proof he was looking for in the unusual formation he discovered.
These rocks are not just any old rocks, they're very special rocks. And the reason they're special is because of the story Hutton was able to tell from them.
Here, two layered rock formations stand at right angles to each other.
He knew these rocks had once been laid down horizontally on the sea floor. They must then have been buried under great depth to recrystallize. They must then have been tilted on end by great earth forces. Then they were eroded away and truncated. Then these rocks were deposited on top. And he realized that that would not take hundreds of years, nor thousands of years, but many millions of years.
Hutton's discovery was a turning point. From that day forward, it was rock, not scripture, that would become the trusted guide to the distant past. And over the next 2 centuries, the study of rocks around the globe would lead to the awesome revelation that this blue-green planet has been on the most astounding journey. A journey that began in a world of fire.
No, I don't think he was. So,
This one. And here's another view of the Earth coming into being.
The journey starts almost 5 billion years ago. There's no sign of Earth just yet. Only the sun, a newborn star surrounded by dust. The Earth hasn't formed yet. But through time, gravity pulls the dust into tiny rocks. To our surprise, something as complex as a planet is made from nothing more than dust and rocks. Over millions of years, gravity pulls these rocks together to form the Earth, one of at least 100 planets circling the sun. But 4.5 billion years ago, Earth looks more like hell than home. Up close, the temperature is over 2,000 degrees Fahrenheit. There's no air, just carbon dioxide, nitrogen, and water vapor. It's so hot and toxic that if we got any closer, we'd be incinerated and suffocated in seconds. This newborn planet is a boiling ball of liquid rock. An endless ocean of lava. A young planet called Theia is heading straight for Earth. The size of Mars, it travels nearly 10 miles per second, 20 times faster than a bullet. The intruder's gravity distorts the Earth's surface. The blast wave races around the planet. It's as though both young planets turn to liquid. Trillions of tons of debris blast out into space. But over the course of 1,000 years, gravity turns the rubble into a ring of red-hot dust and rock that circles the Earth. From this ring, a ball forms, over 2,000 miles wide. It's the birth of our moon. But it's much closer than the moon today. Just 14,000 miles away, instead of 250,000 miles. The sun rises over a cooling Earth and sets just 3 hours later. The Earth is spinning so fast that an entire day lasts 6 hours. The days may pass quickly, but the Earth changes slowly. To understand the making of our planet, we need to fast forward through millions of years. $3.9 billion years ago, a hail of meteors attacked the Earth. It's debris left over from the solar system's formation. Inside the meteors are crystals that look like grains of salt. And inside the crystals are minute droplets of water. These deadly missiles could contain the vital ingredient for life on Earth. Only a small amount of water exists inside each meteorite. But as they bombard the Earth for over 20 million years, pools of water grow. The Earth's core remains molten, but its surface has cooled enough to form a crust. The air is around 170 degrees. In the future, there's a chance we could swallow this very water. Every sip, every puddle, every drop of water in every ocean is billions of years old. And it may have traveled millions of miles to reach us, carried inside a meteor.
What an emphasis. One of the things that I hope you get from this is the time that it takes for changes to occur. The idea of small droplets of water are introduced, and over millions of years, it then accumulates into what covers the planet in water. And I find that just kind of interesting to me because, you know, we see something wrong and we want it fixed and we want change and we want it immediately and think that whatever we have now will never get fixed. Well, you know, we're going to hear about changes that have occurred at the speed that your fingernails grow, that reshape what becomes the planet. So it's just these things that occurred over a long term are the things that define the planet.
The Earth looks more familiar, but it's still a dangerous place. Winds are faster than the most destructive hurricanes today. It's a megastorm, whipped up by the planet's rapid rotation. The moon is so close to Earth that its gravity is overwhelmed, creating huge tides that race across the planet's surface. But over time, the moon moves away, the waves calm down, and the planet spins slower. "700 million years after the planet's birth, life-giving water covers its surface. And scattered throughout are tiny islands. They seem to have appeared from nowhere. So how did they get here? Molten rock bursts through the Earth's crust and rises up through the ocean. Over time, the lava cools, forming a volcanic island. In the future, these islands will join together to form the first continents. Earth now has water and land. It's beginning to look like the planet we call home. But the atmosphere is still toxic, and the temperature is scorching. Life here is impossible. Since the planet's formation, meteors had been pummeling Earth. But now, 3.8 billion years ago, the assault enters a violent new phase. Some things disturb the orbits of these meteorites. In addition to water, the meteors carry something else. As they dissolve, the meteorites release minerals. Carbon and primitive proteins made of amino acids are transported from outer space to the bottom of the ocean. Thousands of feet below the waves, it is dark and close to freezing. But a dramatic illusion is taking shape. Underwater chimneys spewing hot liquid. Seawater seeps down into the earth through cracks in the crust, collecting minerals and gases along the way. This potent mixture is released back out into the ocean, building these towers. Combined with the minerals and chemicals from the meteorites, the water becomes a chemical soup. It's impossible to know how or when, but somehow these chemicals come together to create life. The water is now full of microscopic organisms. These single-celled bacteria are the earliest forms of life on Earth. This is a defining moment in the making of the planet. Microscopic life is underway. For hundreds of millions of years, nothing changes. The only life is single-celled bacteria. To find more complex life, we need to fast forward to 3.5 billion years ago. And a shallow ocean. These look like rocks, or even plants, growing out of the seabed. Each mound is a colony of living bacteria called a stromatolite. These bacteria turn sunlight into food, a process called photosynthesis. It uses the power of sunlight to transform carbon dioxide and water into glucose, a simple form of sugar. And this magical transformation releases a byproduct, a gas called oxygen. Underwater, the stromatolites slowly fill the oceans with oxygen. The oxygen then turns traces of iron into rust, which fall to the ocean floor to form deposits of iron-rich rock. It's this mineral that will one day be used to build bridges, ships, and skyscrapers. Above the waves, the oxygen transforms the atmosphere. These stromatolites are creating the most important element for life on Earth. Without them, virtually every living thing wouldn't exist.
Okay, now this over here. Come on.
That's going to happen 2 billion years.
Okay, there we are. Get to share screen. And now I want to share with you the real story.
Current theories on the creation of the universe state that if it were created at all and didn't just start, as it were, unofficially, it came into being about 14 billion years ago. The Earth is generally supposed to be about 4.5 billion years old. These dates are incorrect. Some medieval scholars put the date of the creation at 3760 BC. Others put creation as far back as 5508 BC. Also incorrect. Archbishop James Ussher claimed that the heaven and the earth were created on Sunday, the 21st of October, 4004 BC at 9 a.m. This too was incorrect, by almost a quarter of an hour. It was created at 9:13 in the morning, which was correct. The whole business with the fossilized dinosaur skeletons was a joke the paleontologists haven't seen yet. This proves two things. Firstly, that God does not play dice with the universe. I play an ineffable game of my own devising. For everyone else, it's like playing poker in a pitch-dark room for infinite stakes with a dealer who won't tell you the rules and who smiles all the time. Secondly, the Earth is a Libra. The entry for Libra in the Tadfield Advertiser on the night our history begins reads as follows. You may be feeling run down and always in the same daily round. A friend is important to you. You may be vulnerable to a stomach upset today, so avoid salads. Help could come from an unexpected quarter. This was perfectly correct on every count, except for the bit about the salads. To understand the true significance of what that means, we need to begin earlier, a little more than 6,000 years earlier, to be precise, just after the beginning. It starts, as it will end, with a garden. In this case, the Garden of Eden, and with an apple.
You might enjoy that. It's a good omens on Amazon Prime if you get that. It's actually a pretty funny movie. Anyway, okay, so that's what we have for today. George, we can open up questions, comments.
Okay, let's use raise the hand function. And we recommend now that you stay in speaker view, and then anyone asking a question will appear next to Sal with a comment or question. So we have one up there. It's not showing.
Bonnie, if you could unmute. I think you had Bonnie up.
Who was that, Sal?
I thought Bonnie had her hand up and she was still muted. Did I?
Okay. Yeah, no, Sal, actually, that was me applauding.
Oh.
One, as someone who taught the previous hour, I've never watched one of your programs before, and I can understand why it is one of the most popular. You're one of the most popular presenters, and we've never met, but I hope to change that soon. That was really, really interesting. Thank you very much, and I'm going to hope that I can watch the rest of this.
Great, thank you.
I know how much work you probably put into finding the videos, deciding what parts to show, and so on and so forth. So thank you very much. I was not I wouldn't have normally shown myself on video, but since I had something to say, I thought you should not be hearing a disembodied voice. Thank you.
Well, great. Thank you very much. I appreciate that. Thank you.
Thanks, Bonnie. I'm sure many of us share your same thoughts on Sal's presentations. I don't know how he does it. And, it's amazing. Okay.
And there, you know, the videos, if you wanted to watch the whole history of it, it's a great production. And there are others that I have with Neil deGrasse Tyson, and one is a video that I got from George from the Smithsonian. So there's a lot of materials out there that if you're, you know, it hopefully sparks some interest in it. They're really well done, and I think they do a marvelous job of explaining it. Yeah.
I feel like we're in jet lag, you know, we have to zoom in through the creation billions of years. It's, I think people are trying to get their heads on straight.
Well, there's a lot of material to cover yet. We're gonna talk about really when, you know, ice covered the planet, you know, where we sit was covered in 10,000 feet of ice. So it just gives you, and mind you, we kind of think, well, everything is settled down and we have stability and permanence. Goodness knows what's lurking, slowly emerging to change our existence. Yeah.
Nancy?
Well, I had heard that bacteria and viruses were both had their beginnings in the ocean. Now, I heard bacteria mentioned there in conjunction with the sun and the plants forming and so forth, but I didn't hear anything about the early virus compounds, whatever they would be called in their earliest stages, being in the ocean too. Is there any truth to that?
But I don't know. I think, you know, as I understand, the virus emergence and transmission really comes from the mammal life, animal life, and, you know, kind of mixing environments, sorts of, it's kind of a defensive mechanism to kill off what might be predators, but I don't know. Yeah. Sorry, Nancy.
Okay, anyone else?
Yeah, we have, but I can't see her name.
Just put a thumbs up, but I don't.
Yeah, we have a hand up in the screen, if you see that. Barbara Shapiro, no, let's see. Is that Barbara there? Can you unmute your mic? Unmute yourself. You're muted. That's why I can't hear you. You're on your iPhone. If you can unmute on your iPhone.
Well, we have Margaret has her hand up.
Okay. Yeah. Hi, Margaret. If you'll unmute.
Do you hear me now?
Yes, yes.
I just finished reading the biography of water, which was interesting. And I thought others maybe find that book interesting also, particularly after the presentation today and the development of water from the beginning of time.
Yeah, yeah.
But I'd share that.
Oh, no. And, you know, I like those histories that kind of take stuff like the history of salt, the history of water, the history of cotton, because it's a different approach to looking at history and bringing, you know, this thing that becomes so essential for our existence. You know, you get a very different perspective of it. And yeah, I find that stuff fascinating. And we're going to see when life emerges from the water. So that will be coming. And then how us humans emerge, which I think you'll find fascinating. At least I found it fascinating.
Hey, Eileen.
Yeah, I just wanted to know, does that book explain where the water came originally from that came down in the meteorites? I mean, it came where did that come from? See, I know that we're going to look at our own Earth, but the whole universe kind of blows my mind.
Yeah.
Where did it come from? I mean, my mind is too small for it.
Yeah, yeah, no, it's you know, it's difficult for me to get my brain around the formation of our planet. The universe totally blows my mind, and mind you, most of that is theoretical. So we may think the universe is 12 billion years old, 20 billion years old. It's a guess, and then if it is, let's say, 12 billion years old, what the hell was there before that?
That's what I want to know. See, that's what I want to know.
And what's outside of there?
Somewhere.
You know, way beyond my...
It's too much.
Okay, Tom.
Sal, I'm of course, very much of a layman in this area of expertise. Not like you, your expertise is beyond the scope of my intelligence. Is the centrifugal force the foundation of why the Earth and the Moon is round?
Yeah, I guess you could look at it as centrifugal force. It's also gravity that is, you know, forcing these things together. Forcing, you know, it kind of brings metals down to the lower end of the ocean, and we have to, you know, as we go on, we extract it. We have to dig down to extract some of these heavier metals. Yeah, it's the mix of it. I think the idea of that cloud and the spinning and items, what do they call it? The aggregate, you know, all coming together and forming one solid surface is kind of just, you know, conceptually to me, fascinating to look at. As to this thing that we think of as the solid Earth was not. It was a cloud. It was a cloud. Yeah.
The reason I asked the question was, you know, it sounds silly, but the Earth could have been square. I don't know. You know, that's why I'm saying the centrifugal force is the problem.
Sure. Could have been. It could have been, and then reshaped over time. Right. We think of it as a circular thing, but is it a perfectly circular thing?
No,
probably. Right.
Yeah.
Bonnie?
I was going to say that when you were talking a couple minutes ago about putting things into perspective and this idea of millions and billions, I mean, I couldn't help when you first showed the first slide, and I can't remember what it exactly said, but it said like 4.3 to 4.7 billion. And I'm thinking, oh, a billion here, a billion there. It, you know, I guess it all adds up. But here we're sitting, I'm looking at my watch and thinking, oh, we got one more minute.
Yeah,
and
right.
It really is interesting to me to think of that, the big picture, which is way big, but what we think of as the big picture or even our own little small picture. I went through years of infertility, and it ticked me off that Mother Nature doesn't care who has a baby as long as somebody does.
Yeah.
And it infuriated me.
Sure.
And to a certain extent, it still does. And in today's day and age, people are still thinking about that. So anyway, that whole concept of time here and here, which is relevant also to the class I'm teaching before this.
No, look, as I said before, I as an undergraduate student fresh out of Vietnam. I wanted to see changes happen immediately. And I had a history professor, advisor, friend who I was on some, political tirade and how everything has to happen now. And he listened to me very politely. And when I finally shut up, he said, obviously, I've taught you nothing. You think everything should turn immediately. History happens over the long term. And that really had affected my thinking greatly, which is why really in my world of security, what I really didn't, you have the event that happened, let's say on July 4th. We have what happens there. Yes, we have to deal with that, but I'm much more interested in the broader picture. What were the forces that came together to make that happen? And that is where I think we start to really understand the disease as opposed to the symptom. And when you start contemplating things happening over millions of years and billions of years, very slow, but that's going to be the what is going to be more long lasting and impactful. So yeah, in fact, one of the classes I'm working on for winter is there's all the talk about Trump and January 6th and all of that, which is certainly understandable and stuff that people should want to know about and all. But I want to really look at a broader picture over 100 years of what are the forces that converge, that manifest, that how did we get to here politically? It's not just one person came along and did this. It's something that has evolved over a period of time, and we need to understand those broader forces if we're going to do anything significant about it.
Okay, Joy?
Yeah, just a quickie. When I was in college, for a while as a mercenary, I taught Sunday school and Hebrew school. So when I had one of those Sunday mornings after Saturday nights that I couldn't, pull anything together, I figured I'd pull out, in the beginning, God created the heavens and the earth. Okay, easy enough. So then one of my little students, who was about 10 years old, says, Miss Glucksman, what was there before? And we went round and round on nothing. The only way I could shut him up was to say potential. And I still think of it as that way. And we still don't know the potential of the universe.
Sure. Yeah. Well, that's interesting. Yeah, great. Thanks, Joe.
Okay, Barbara?
If it took all that time to get all this done, how come we seem to be able to unmake it so easily? I mean, have you been outside recently?
Have I done what?
Have you looked at your electric bill?
Yeah.
We've certainly managed to change the climate. I mean, glaciers are falling, pieces are falling on people. Why can we make such a difference? We puny little people.
Well, we're gonna look at that in the sixth class about the people will say, well, the Earth's temperature has changed all the time. It's gone from 2,000 degrees to 50 degrees. Well, that's true. Only the changes took place over millions of years. We're seeing the climate change over 200 years. And that is very significant. It's a much more rapid pace than what was
that's
what was
right and proper.
So yeah, well,
call cannot be completed as dialed.
Yeah.
Arnold?
Who was that?
Yeah. So as you were talking about the age of the Earth, I was thinking back to a show that I heard on radio where they actually interviewed the fellow who did the calculations for that. And I don't know, are you going to get into this as to how they determined that age?
Well, that was part of the video that was with Neil deGrasse Tyson, that you have. There's the one scientist who's crunching the numbers and saying, here's how it came together. And then there are others who have other theories.
Well, so what this fella did, he thought it would actually be easy, but it's based on the radioactive
Right, right.
and it goes to lead. And so he had a meteor that came to Earth, what they thought was at the time that the Earth was formed. And he had to analyze the lead in that meteor, just micro amounts, and then based on that do the calculations.
Yeah.
The interesting thing was that in order to do this, he had to have a lead-free laboratory. And every time that he tried to measure to get a zero reading, he couldn't. So he, changed his clothes, he washed his hair, he did everything he could, and nothing worked. And then what came to be was, this was back when we were using leaded gasoline in our cars. And so there was lead in the air everywhere. And so it was his work which pointed out the wide distribution of lead in our environment, and eventually led to taking the lead out of the gasoline. So it's sort of a fascinating story as to how they got that first most accurate dating of the age of the Earth.
Yeah, there's another documentary series which is titled "How the Earth Was Made," and that has a clip of when they started looking at meteors where they hit, and that's when they started finding some fossils that would go back to 4 billion years ago, and they started measuring the radioactive aspects of it. But I didn't show that one. I had that as a backup to this last one that I just showed. But there's just, but it's really fascinating to look at. Yeah.
Okay, well, let's ask everyone to unmute so we can thank Sal for a great start.
Okay.
History of the Earth.
Thank you.
Thanks, everybody.
Thank you.
We'll see you next week as we move into our next one is going to be Rodinia. We're going to look at Rodinia next week. So.
Rodinia.
Yeah. A billion years ago. That's when it was planet ice. Planet ice.